To Agos. Okay, so we're going over our warm-ups today. The warm-ups were the back of yesterday's warm-up, so if you're absent, that's where you can find them, on the back of yesterday's warm-ups. So number one, ask us to first draw in a segment AC. Now we had no one like this, but let's do it. Draw in a segment AC. And when I give you a new one like this, I give you both parts. I give you the statement, I gave you the reason. Any two distinct points can form a segment. And that's why we can draw it in there. And then we were given that ABCD is a parallelogram. That was given. Therefore, we know that AB is parallel to DC. Parallel. And we know that AD is parallel to BC. Two ways you can justify that. You can either say that's the definition of a parallelogram, which it is. Or you could say that in a parallelogram, opposite sides must be parallel. Now, because we know these are parallel, we know that angle DAC, right here, would have to be congruent to angle BCA, right here, because the alternate interior angles are congruent. We also know that DCA, which is the angle right here, would have to be congruent with this angle here. Then the next statement is that AC is congruent to itself. When we have something congruent to itself, what property is that? Reflexive. So if I got rid of the parallel lines so we could see what's there. There we go. Do you guys see we have two congruent triangles? We have triangle ADC that is congruent to triangle CBA. And they're congruent by angle side angle. So if we have congruent triangles, then corresponding parts of those congruent triangles must be congruent, which is what CTC stands for. So we know that AB must be congruent to CD and DA congruent to BC. Now, earlier today somebody said, well, because it's a parallelogram, we know this is true. That's one of those 5 or 6 facts we have about a parallelogram. But to prove it's true, you can't use that statement. You have to go through and prove, in this case we use congruent triangles, to prove that that statement is true. Any questions about the first one? Okay. Those of us that were concerned about proofs, are we okay on these?
Yeah, I did better on this one.
I got one.
Yes.
Are we gonna have to like fill in the blanks on our test?
Yeah.
That's easy.
Are we
better than
we're not
create it
gonna,
all
we're not gonna
yourself.
have to create one all by ourselves?
I did not put one that you have to create the whole thing. Yeah, that was old school. When I was in high school, this is what they gave me. That's it. They gave me that, and they didn't even give me a picture. I didn't even draw the picture. They just said, given this, prove this, and we did it all.
What was it like in college when you had to write
The proofs, it was proofs. It was non-Euclidean geometry. It was very different.
Was it harder?
Yes. Yes, most graduate level math classes are harder than 9th grade math classes.
Hey, well, you never know.
Not all of them. Not all of them. Yeah. Okay. All right, here we go. I know. Given parallelogram ABCD, so they told us it's a parallelogram again, and with diagonals AC and BD. So that's already drawn for us. We've got the picture. It was given. Good. AB is congruent to CD. Well, yes, because when we have a parallelogram, both pairs of opposite sides are congruent. AB is also parallel to DC. Well, sure it is, because in a parallelogram, opposite sides are congruent. Or you could use definition of parallelogram here again. So far, so good?
Yep.
Okay, now because these are parallel, we know that alternate interior angles must be congruent. So angle BAC, this one right here, I'm going to get rid of parallel for a second. This angle here must be congruent to this angle here, because they are alternate interior angles to these two parallel lines that I just erased the parallel symbols for. Now, the other thing they give us is that this angle here is congruent to this angle here, because vertical angles are congruent. So if we look at our picture, we have this angle congruent to this angle congruent to this angle, and this side congruent to that side. So we have triangle congruency statement that we can make. Triangle AOB is congruent to triangle COD. That angle side congruence postulate.
I have a question.
Yeah.
Couldn't you do side to side too?
We could with a different proof. But this proof, the way this one has lined it up for us, gives us angle side. But we could do side, angle, side, but we would have to look at it differently.
Because I don't know why, but I ended up marking the diagonals for bisecting just from knowing that it was a parallelogram. So
We can do that, but then somewhere in here has to be that statement
okay.
that AO is congruent to OC.
So it has to be listed, not just now.
It would have to be listed and not just known.
Okay.
Very good point there. Did everybody hear that? Dalton, that was a good thing he just said. We know that the diagonals of a parallelogram must be congruent, but in a proof, unless it's stated, you cannot assume. Okay? Yes, ma'am.
Then why did you have to prove the fact that it was a parallelogram with the first one?
I was given.
You have to be given something to start with. So I gave you parallelogram to start with. We're proving that the diagonals are congruent.
But in the first proof, why couldn't we just say, well, we know it's parallelogram, so then AB and DC together?
Because you can't use that to prove that what we're trying to do in this problem is prove that that statement is true. So to prove that that statement is true, you can't use that statement itself. You have to use other supporting evidence.
Okay.
All right. So then we get down here to those two angles, vertical angles, angle, side, angle. So then we can say that corresponding parts of congruent triangles are congruent. So what we're proving is that the diagonals bisect each other. So all of this proves that diagonals do, in fact, bisect each other. Now that's not the only way to do the proof, but that is one way to do the proof. Okay? All right. You guys may have checked some of these yesterday. This was on your constructions. I've circled the correct answer. The answers were also on the board yesterday, for those of you that were here.
Hey, I got the first one. Sure, look good. I got it.
Yes.
Last time when I was doing this, I was trying to look on the website for the answers, but I couldn't find it.
Yeah, same here.
The answer is the packet. Nobody posted it tonight.
Okay.
In today's notes, it'll say March 13th. And all the answers will be up there. Even to the stuff that I didn't assign. Okay. 5 and 6. We good?
I'm just gonna guess we're gonna have to know how to do it.
There are constructions on the test. Well, I give you some on the review. There might be somewhere you have to put it through the
I like this. Cause like,
Yes.
number 5. I got that one.
Number 5. All right. I will try number 5. I'm going to attempt it. Okay. Now, doing it on this thing is tricky to get it just right, and those letters are really close. That may have been your problem too. Was that your problem?
Yes.
It's tricky to get it just right, and the letters are really close. Okay, I made several different versions of this before I was satisfied, and I really don't see how you could miss the one I gave you. Okay, so first thing we do is we do an arc. Next thing we do is, whoops, that's not what I meant. Hold on. Edit, undo. Okay, that's what I meant to do. I'm just measuring, but I don't think, there we go. That's on the right spot now. Measure from there to there. Okay, and then we'll slide it down to here. And then we'll swipe. And then we'll draw in our line. And what was the answer to number 5? D. Mine's close to D. It's not on it, but it's close. Okay, let's take a look at the back. You should have gotten C, B, C, D.
C. I was on the roll.
Wow.
I have a good one, but I have another
You
one.
won
The
mine.
lead is getting really low, and I don't know if it's going to get off from there and stay.
What's your name?
No, I know. I have one.
This little thingy.
We don't. I don't have one.
I get earned
Okay. Let's take a look at this.
That's my problem.
All right. The first one, number 7, DAB is equal to BCD. Okay, so I have one pair of opposite angles congruent. Is that enough? No, it's not. That's not. Okay, the next one, I have AB is equal to DC, and AB is parallel to DC. Is that enough?
No.
Yes. I have one pair of opposite sides that are both congruent and parallel. Look at your parallel. Look at your little half sheet. That's one of them. Okay, number 9. I have AB congruent to DC and AB parallel to DC. Same problem, isn't it? Yes. Except here they said equal length, which meant congruent, and here they said congruent. Okay, number 10. I have angle 1 congruent to angle 5. Ooh, that tells me that AB has to be parallel to...
This is the converse theory of alternate interior.
Yes, it is. It's the converse of the alternate interior angle theorem. Awesome. Then I have angle 2 congruent to angle 6, which just verifies the fact that these two have to be parallel, because that's another converse of the alternate interior angle theorem. So I have one pair of parallel lines. Not enough. I only have one. Okay. Number 11. Angle 4 is congruent to angle 8. Okay. Converse of the alternate interior angle theorem tells us that AD would be parallel to BC. And then I have angle 1 congruent to angle 5. Oh, yay. So that's the second one. So CD would have to be parallel to AB. I have two parallel lines. Two pairs of opposite sides parallel. Yes. Okay. The next one, I have triangle ABD. ABD. So this one, ABD, congruent to, let's switch colors so we can see it, ADC. So, this gives me that this is congruent to that. That's all I got. Do y'all see anything else? Is that enough?
No, it's not.
No, it's not. All right. AB parallel to DC. And AD parallel to BC. That's definition of a parallelogram, isn't it?
That's pretty straight up
Yes,
right there.
yes. No confusion there. Okay. AB congruent to DC. And AD congruent to BC.
Yep.
Yes.
Amen.
Two pairs of opposite sides are congruent. AE, EC, BE, and ED. Is that enough?
Yes.
Yes, angles bisect each other. Okay, last one is another triangle one. So AEB, okay, congruent to CED.
I'm gonna have to say no.
Okay, so, well, let's mark my corresponding parts that I know. I know this is congruent to that, but that's not enough. I know that this is congruent to this, and that this is congruent to that.
How do you know that?
Because corresponding parts of congruent triangles are congruent. So I know my angles, my diagonals are bisected. That's enough.
I hate my legs.
Okay,
Don't bring yourself down, man.
it's all right, Matt. I'm sure you got most of them right.
Yours can't.
Yeah, well, I'm pretty good at volleyball.
All right.
I actually did.
I actually like. Can we actually take that on our test?
No!
You know what? I
said
think that's a great idea.
Oh my gosh! For bonus. For bonus. Yes, this is like the easiest thing on the study guide.
Okay, it's like mutiny. I've already run off the test and it's on there, so.
Oh, okay. Yeah.
I mean,
Too late.
it's not like it was anybody. I'm glad you like my idea.
It was so easy though.
Okay,
It was.
I like
Yeah,
it.
well,
angle puzzles. Angle puzzles. All right. So,
I like it.
the reason it's on there is because it does everything we talked about. You have to use triangle sum theorem. You have to do the sum of the two exterior angles is equal to the remote interior angles is equal to the exterior angle. We've got parallel lines. We got corresponding angles, alternate interior angles, alternate exterior angles. You can use it all. Vertical angles. All right, so these are parallel, so let's go ahead and just throw in those corresponding angles. We got them. Those are corresponding. Okay? These two form a linear pair. So if that's 80, then that's 80, and that's 80. Well, these are vertical, so that's got to be 80, and that's got to be 100. That's got to be 80, and that's got to be 100.
Wait, how did you figure out NGF equals 80?
N
G is down.
G F. Because these form a linear pair, and if this is 100, that has to be 80.
Was 100 given to us?
Yeah.
100. This 100 right
Oh,
here was
it's
given to you.
corresponding.
All right. Now, this is 140, so that leaves 40 there. Got that one? Okay. If this is 75, then this has to be 75. And if we added these up, we know that has to be 75 because the three angles have to add up to 180, and they do. So if this is 75, this is 105. And if this is 105 and this is 130, what does it leave here?
45.
45. Okay, so if this is 105, this is 75, and this is 105. Do all four of these angles add up to 360?
Yes.
They better. Good. So this is going to be 105, and do all four of these add up to 360? Yes. Okay, if this is 75, then this is 105. These are vertical angles, so this has to be 75. So 75 and 105 and 65, can we figure out what this angle is?
Yes.
115, because they have to add up to 360. This is 105. And this is my last angle I can figure out. What is this one? 95, because they have to add up to 360. So there's a couple right here. This angle we can't figure out. This angle we can't figure out. This angle we can't figure out. And this one.
So this exact problem will be on the,
No. It'll be a different triangle puzzle.
but a triangle puzzle.
A triangle puzzle.
Okay. I can handle that.
Well, I got all of them.
You're such a good friend.
Okay. More proofs. Alright. Right angle. Right angle. Yes, congruent to this. This is congruent to itself. Guys, we're moving on. Reflex it. Alright. Now, I already can see triangle congruence. So I'm going to keep it in the order that it looks like here. Nice and neat. Triangle DOS is congruent to triangle GSO by, what's the congruence postulate? Hypotenuse leg. Good job. Alright, therefore, angle DOS is congruent to angle GOS because corresponding parts of congruent triangles must be congruent. Okay. Questions about that? Alright, let's say on your test tomorrow, I didn't say that. Let's say I said prove that DOGS is a rectangle. So, we wouldn't need this line. We would come down to here, And what could we say? Who's got that?
Oh, you could say DO is
DO
congruent to
and
SC.
Okay, why is that helpful?
Because opposite sides are congruent.
Okay, so DO is congruent to SG.
DS is.
Because corresponding parts of congruent triangles are congruent. Now the reason that's helpful is because now I have two pair of opposite sides congruent, which proves what?
Rectangle.
No,
What's proof parallel?
Parallelogram. So we would say DOGS is a parallelogram because
Because of opposite sides are congruent.
congruent opposite sides.
two pairs of congruent opposite sides. Two pairs of congruent opposite sides. And we would probably say something like it's a quadrilateral with two pairs of opposite sides.
And then two
Now
right
you have
angles.
to say that.
Okay, now we've already said right angles right here. Is that good enough?
Well, because
Okay.
you've got the
So now we can just go ahead and say that dogs is a rectangle
Because of right angles.
It's not rectangles.
because it's a parallelogram with a right angle. And that's all I need. Cool, huh?
C.
Wait, what does that mean when you have the little thing with right angles or those angles on it?
There you go.
Is it different? Does it mean the same thing?
Yeah.
With the little, it does mean something different? What does
Yeah.
that mean?
Same.
I know.
All right, here we go. CA is congruent to AT.
Definition of midpoint.
Definition of midpoint. Okay, AS is congruent to itself. Reflexive.
Come on, Renee. Watch this stuff.
And it told me up here that this is congruent to that. So I know that triangle, let's go with CAS.
Yes.
Triangle CAS is congruent to triangle TAS. By how? Side angle side. Okay, now I know that CS is congruent to TS because corresponding parts of congruent triangles are congruent. Okay, this one, did you get angle 1 and angle 2 are vertical angles?
C. Sure did.
And vertical angles are what? Congruent. So did you say triangle something like this?
ETC.
I said TEC is congruent to triangle TAG. Tag tag. By SAS.
Yep.
And therefore EC is congruent to AG by corresponding parts of congruent triangles are congruent. Are we good? And this one, I marked this wrong in a class earlier and then I tried to do something you can't do. It says 5 is congruent to 7 and 6 is congruent to 8.
Oh, I think I did what you said you can.
At first I marked them 5 and I marked them across, which was not right. So, reflexive is probably looking for AC congruent to itself.
Yep.
So now I have congruent triangles, but I have to be careful. I've got triangle AJC congruent to triangle, okay, AKC. By angle side angle. Therefore, angle J is congruent to angle K.
Wait, what'd you almost do wrong?
Corresponding parts of congruent triangles are congruent. I marked it like this. I marked this with this. I wasn't paying any good attention, and this with this. And then I tried to make the claim it was a parallelogram. But I marked it wrong. So I can't make that claim.
How about all
Oh,
four of them?
are you trying to do the same thing you did with the rectangle? That we could just transfer it over to that.
I can prove height, but I can't prove parallelogram. So I have one pair of bisected
Oh, okay.
angles.
kite on a test?
Prove kite. No.
Okay, so we have practice that much.
Okay, so for those of you that did the additional practice, if you go to today's website and check the notes, all of these answers are attached to the bottom of the notes. Here's the back. Another angle puzzle, those of you that love the angles. Okay, so what was left out of the review? What was missing?
All my
Center.
children bought a cookie.
No.
Oh God, no.
Okay,
No.
all of my children are bringing in
Peanut
butter cookies. Okay.
Ortho Center.
Unfortunately, that will not be written on the board tomorrow. So an altitude gives me the orthocenter, medians give me the centroid, angle bisectors give us the incenter, and perpendicular bisectors give us the circumcenter. Okay, medians, midpoint to the opposite vertice. Okay, midpoint to the opposite vertice. Oh, that's awesome, isn't it? So, I can't even do that. That's terrible.
That was awesome.
All right.
That's great.
Yeah. We'll call it. All right. So it would have to be marked in some way, shape, or form. But when we have a cool one like this, if this is 10 and this is x minus 2, can we find x?
Yes.
Yes, because what do we know about the centroid?
2 to 1.
It's a 2 to 1. This is center of gravity. It's 2 to 1. So we would have to know that x minus 2 would equal what? 5. So what is x?
3. No, 7.
7. Okay, so we can do some algebra there. All right. What do we know about? Let me just open them up. These are fun.
Whoa, it looks great.
Okay, so here is a centroid, and I drew these on GeoSketchpad so you can see what happens. This is cool. All right, so do you see that these are all going from vertex to midpoint? Vertex to midpoint of opposite side, vertex to midpoint of opposite side. So no matter where this vertex is, do you see that it stays inside the triangle?
Yes.
Okay, and does it look like it continues to be in a 2 to 1 ratio, no matter how I do it?
Relatively.
Yes, it does. Okay, so, whoops, that's what I meant to do. I just meant to, how do you minimize?
The little minus button.
Minus button.
That minus, okay. Now let's look at the, I don't even see it. The orthocenter. Okay, so the orthocenter is formed by the altitude. So it goes from a vertex and it's perpendicular to the opposite side. Vertex perpendicular to the opposite side. Vertex perpendicular to the opposite side. Oops. That doesn't matter, I'll move it around. Now this is the one that can be inside, outside. See, it's inside, it's outside, it's
so
on. So the orthocenter could be a couple places, inside, outside, on. Got it?
I don't like
That is so sick.
Okay. In center. Whoops. Is that what I want? Nope, that's not the one I want yet. On this one. Yes. In center is formed by the angle bisectors. Do these look like angle bisectors?
Sure do.
It's always inside the circle, and it's equidistant to an edge. This distance, not that one. This distance and that distance will always be the same, and you can form the circle with it, which I did here. Go away. Go away.
What are you talking
Okay,
about?
so see, I formed the circle in there. And so the circle always stays in there no matter what kind of triangle I make. The circle is inside. Okay, so how could I give you a question like this on your test? I could give you the in-center by showing you this. Okay, so show you that this is the angle bisector, this is the angle bisector in center. Then what I could do is draw down a perpendicular here. Let's pretend like it attaches to that point. Draw down a perpendicular there. and then tell you that this distance is 12, this distance is 13. What is that distance?
What the heck?
What?
What is that distance?
Huh?
What?
You just confused us all.
Well, watch this. Yes, you do.
I said that.
Good, Shannon. You do the Pythagorean theorem. X squared plus 12 squared equals 13 squared. And so x squared equals 169 minus 144. X is 5. So if this distance is 5, this distance must also be 5 because it is equidistant to the sides. The end center is equidistant to the sides.
That makes sense.
Okay, now the last one I want to show you is the circumcenter. Alright, so it is formed by the perpendicular bisectors. That's what all those red lines are, the perpendicular bisectors. And then all I did was I constructed a circle going from this point to one of the vertices. Okay, so what we could do is I could show you that the circle will always be around no matter what.
Oh my.
See, the circle is always around the triangle no matter what I do with it.
This is so cool.
The circle is still around the triangle even when I switch
But the
vertices.
circumcenter can be anywhere, can it? Or no?
Yeah, the circumcenter can be inside, outside, or on. Okay?
Is the circumcenter the dot in the middle?
The circumcenter is the intersection of the three red lines, which is right there.
Oh, that's why it's similar to the, I would say.
Because it can be inside and out.
It can be inside, out, or on.
I had to say that.
No, this is what circumcenter. Circumcenter can be inside out. How do you know? Well,
Shove me down for
you can put this, you can either
Actually, it can't be on the circle. It's got to be inside or outside.
I could tell. I was like, I don't carry any of you. So you both would sleep out there, and I would wake up and I'd be in the bed.
Okay, yeah. Yep. If it lies on the intersection of the perpendicular bisector and the triangle. Yeah. Okay. So those are our triangle centers. I hope maybe that was a little bit helpful, seeing them in action.
I will let you money this.
Okay.
When you, on the test, if you do a circumcenter, will it always have a circle and then a triangle in it?
On the test, it won't have the circle. It'll look like this without the circle. So what I do is I take that circle and I delete it. Hold on, I can do it if I want. How'd you know? Because you would see perpendicular bisectors. You have to know that that is the circumcenter because it's formed by the perpendicular bisectors. Perpendicular bisectors, and it's equidistant to the vertices. This point right here is the same distance to each one of those, and I can actually measure that distance. Let's do measure distance. No, from here to here, not from A to B. And it's not letting me do what I want to. Well, because I'm not doing it right. Alright. So there were optional problems that you could try, and I have not posted those solutions. I said I would. I'll go do that right now. Okay?